5 ways policy gradient methods are revolutionizing artificial intelligence technology. Are you interested in how cutting-edge technology will shape artificial intelligence in the future? Are you prepared to learn the techniques used by artificial intelligence agents to adapt and learn in challenging environments? We go deep into the world of policy gradient techniques, the revolutionary technique transforming artificial intelligence technology in this engrossing video. How do these techniques allow artificial intelligence agents to precisely explore complex environments? Why are they so scalable and effective even in environments with limited resources? Come along on a fascinating exploration of 5 ways that policy gradient methods are changing the artificial intelligence field. Watch now to discover the possibilities of artificial intelligence technology and don't miss out. Policy gradient approaches are a novel approach that is creating remarkable improvements and capabilities in artificial intelligence technologies in the quickly changing field of artificial intelligence. These techniques, which have their roots in reinforcement learning, provide a flexible framework for teaching artificial intelligence agents the best courses of action in challenging and unpredictable situations. In this video, we examine 5 significant ways that policy gradient methods are advancing artificial intelligence research, creating new avenues for investigation, and influencing the direction of intelligence systems in the future. Enhanced learning in complex environments. A keystone in the development of artificial intelligence technology is enhanced learning in complex environments, especially when viewed through the prism of policy gradient techniques. In contrast to traditional learning paradigms that depend on explicitly stated instructions and labeled datasets, policy gradient approaches present a dynamic framework in which artificial intelligence agents learn through direct interaction with their surroundings. This novel method provides unmatched flexibility and robustness, particularly in settings with high-dimensional state spaces, complexity, and uncertainty. Policy gradient approaches excel in fields where traditional rule-based systems find it difficult to handle the complexities of real-world dynamics, such as autonomous systems, robots, and video games. These techniques enable artificial intelligence agents to investigate a wide range of feasible tactics through iterative trial and error, progressively improving their policies based on the observed results. Policy gradient approaches effectively navigate the large space of possible actions by utilizing techniques such as Monte Carlo sampling and stochastic gradient descent. This allows them to optimize performance and make real-time strategy adjustments. Policy gradient approaches enable artificial intelligence agents to learn from experience, identify patterns, and find the best solutions to challenging situations by utilizing the power of reinforcement learning. With its innate ability to improve learning in intricate settings, artificial intelligence is poised to make significant strides in a variety of domains, including robotics, financial modeling, autonomous driving, and personalized medicine. Policy gradient approaches are set to transform artificial intelligence technology and the way we engage with and utilize the promise of intelligent systems in our ever-complex world as they continue to progress. Sample efficiency and scalability. Policy gradient approaches, which address fundamental issues in data-driven learning, have the potential to revolutionize artificial intelligence research and applications. 2 key components of these methods are their scalability and sample efficiency. These techniques differ from conventional supervised learning paradigms, which frequently call for the use of sizable labeled datasets in order to successfully train artificial intelligence models. Rather, policy gradient approaches make artificial intelligence agents more sample efficient by allowing them to learn directly from their interactions with the environment. Policy gradient approaches quickly explore the space of possible policies by utilizing techniques like Monte Carlo sampling and stochastic gradient descent, allowing for performance optimization with less data. In fields like robotics, healthcare, and scientific research, where gathering data is expensive, time-consuming, or impractical, this sample efficiency is very helpful. Moreover, policy gradient approaches are remarkably scalable, able to manage complicated action spaces and high-dimensional state spaces that are encountered in real-world scenarios. These techniques are appropriate for a variety of activities and domains because they can scale to large-scale, real-world situations by utilizing distributed computing and parallelization, which are 2 key components of contemporary computing infrastructure. The scalability of policy gradient approaches is further improved by developments in hardware accelerators and cloud computing, which empower academics and industry professionals to take on bigger and more complicated artificial intelligence projects. Consequently, policy gradient approaches have emerged as essential instruments in the artificial intelligence toolbox, propelling progress in domains spanning from robotics and reinforcement learning to natural language processing and autonomous systems. Policy gradient approaches are making significant strides in artificial intelligence research by tackling the problems of sample efficiency and scalability. This opens up new avenues for intelligent systems to learn, adapt, and flourish in a variety of dynamic contexts. Adaptability to diverse tasks and objectives. As a flexible and dynamic framework for learning and decision-making in complex situations, policy gradient approaches have played a crucial role in the evolution of artificial intelligence due to its adaptability to a wide range of tasks and objectives. Policy gradient methods make use of the ideas of reinforcement learning to allow artificial intelligence agents to learn directly from their interactions with their environment, in contrast to typical machine learning approaches that frequently require task-specific data and algorithms. Policy gradient approaches can be used to a wide variety of problem domains, learning objectives, and constraints due to their intrinsic flexibility. Policy gradient approaches can be tailored to meet the individual needs of various activities and domains, whether the goal is to achieve specified goals, maximize cumulative rewards, or learn from demonstrations. In real-world applications where activities may be ill-defined, dynamic, or susceptible to changing situations, this adaptability is very essential. Furthermore, policy gradient methods facilitate the incorporation of domain-specific restrictions and knowledge, allowing artificial intelligence agents to make use of past data and knowledge to direct their learning and decision-making procedures. Consequently, policy gradient methods have been used to a wide range of industries, including gaming, banking, healthcare, robotics, and autonomous systems. This has led to breakthroughs and innovation in these fields. In addition, current research endeavors persist in broadening the capacities and relevance of policy gradient procedures, investigating novel algorithmic approaches, optimization tactics, and learning frameworks to address progressively intricate and demanding assignments. Policy gradient methods are set to play a pivotal role in shaping the future of artificial intelligence by providing a versatile and adaptive framework for learning and decision-making. This will allow artificial intelligence agents to navigate the intricacies of the real world with intelligence, efficacy, and efficiency. Robustness to partial observability and uncertainty. A key component of policy gradient approaches is robustness to partial observability and uncertainty, which transforms artificial intelligence's capacity to navigate complex and dynamic situations. Artificial intelligence agents frequently encounter circumstances in real-world settings where they are uncertain about the results of their decisions or do not have full knowledge of their surroundings. In order to overcome these obstacles, policy gradient approaches embrace probabilistic thinking and uncertainty, allowing artificial intelligence agents to make judgments in the face of imperfect knowledge. Policy gradient methods use probabilistic representations and reinforcement learning algorithms to evaluate the value of actions and reason about uncertainty more effectively than deterministic approaches, which may find it difficult to handle uncertainty. Artificial intelligence agents can navigate uncertain situations with certainty and efficiency by utilizing a probabilistic framework that allows them to balance exploration and exploitation by analyzing the possible risks and rewards of various activities. This resilience to partial observability and uncertainty is especially useful in fields like autonomous driving, robotics, and financial trading, where environmental dynamics are stochastic or unpredictable. For example, artificial intelligence agents in autonomous driving have to make snap decisions based on imperfect information from sensors, traffic patterns, and road conditions. These agents can adjust to changing conditions and make well-informed judgments that put efficiency and safety first thanks to policy gradient approaches. Similarly, policy gradient methods enable artificial intelligence agents to evaluate risk and optimize trading strategies in real time, maximizing returns while reducing losses in the extremely uncertain and turbulent world of financial trading. To further increase their resilience and flexibility in uncertain contexts, policy gradient methods facilitate the integration of probabilistic reasoning strategies with uncertainty-aware models. Artificial intelligence agents can learn more resilient and adaptable policies that effectively handle environmental variability and generalize to new circumstances by introducing uncertainty into the learning process. This capacity is crucial for developing artificial intelligence systems that can function well in dynamic, unpredictable, real-world environments where things might change suddenly and drastically. All things considered, the resilience of policy gradient techniques to partial observability and uncertainty marks a noteworthy turning point in the development of artificial intelligence, paving the way for intelligent systems to function independently and adaptively in challenging and uncertain situations. Policy gradient approaches have the ability to propel innovation and advancement in artificial intelligence technology indefinitely, as research in probabilistic reasoning and reinforcement learning advances. This bodes well for the day when intelligent systems are able to function well and navigate in the face of uncertainty. Continual learning and lifelong adaptation. The fundamental components of policy gradient approaches are lifelong learning and adaptation, which allow artificial intelligence agents to change with their surroundings and tasks and gradually pick up new information and abilities. Policy gradient methods provide a dynamic and adaptable framework that facilitates ongoing learning and adaptation to a variety of changing contexts, in contrast to classic machine learning techniques that are frequently restricted to particular tasks or domains. In real-world applications where activities may be complicated, dynamic, and prone to change, this capacity is very valuable. Policy gradient methods use strategies including experience replay, transfer learning, and meta-learning to help people gain knowledge and abilities that they can use for a variety of jobs and domains. Artificial intelligence agents can generalize from prior learning and modify their tactics to new difficulties with little oversight or more training data by drawing on prior experience and applying knowledge to novel scenarios. Furthermore, policy gradient methods facilitate the incorporation of domain-specific restrictions and knowledge, allowing artificial intelligence agents to make use of past data and knowledge to direct their learning and decision-making procedures. Building artificial intelligence systems that can function well in dynamic and changing situations, where conditions may change quickly and unpredictably, requires this capacity for continuous learning. Policy gradient approaches enable artificial intelligence agents to handle complicated and uncertain situations with intelligence, flexibility, and resilience by continuously improving their policies via experience. This leads to breakthroughs and innovation across numerous sectors and domains. Policy gradient approaches have the potential to propel artificial intelligence technology forward and allow for continuous learning and reinforcement learning in intelligent systems. This bodes well for the development of artificial intelligence agents that can learn, adapt, and prosper in a variety of dynamic and varied environments in the future. A new paradigm in artificial intelligence technology is represented by policy gradient approaches, which provide a flexible and effective framework for teaching intelligent agents the best courses of action in challenging and unpredictable situations. These techniques are creating new avenues for exploration and transforming the landscape of artificial intelligence technology, from improving learning in complex situations to facilitating sample efficiency and scalability. Policy gradient techniques have the potential to propel innovation and technological advancement in artificial intelligence as reinforcement learning research advances, paving the way for the day when intelligent systems are able to adapt to a wide range of changing conditions and survive. Unlock the power of continual learning and lifelong adaptation in artificial intelligence. Subscribe now to stay updated on the latest advancements and innovations shaping the future of intelligent systems.